let us go for problems on the fundamental particles, atomic number, mass number, isotopes, isobars and all, plus nature of life. So we'll solve problems right up to the topic nature of life. Okay. Now let me give you the first and the very interesting question, that is, arrange electron, proton, neutron and alpha particle in the decreasing order of their E by M, I mean specific charge values. So this is very interesting. You have to arrange electron, proton, neutron and alpha particle in the decreasing order of their E by M. You know, specific charge is nothing but electrical charge by mass, right? Nothing but E by M. Now let us just check the things given. We are given electron, we are given proton, then neutron, and of course the alpha particle. Okay. See, if you look at the things given, what all are written as a subscript are the charges, and what all are written as a superscript are mass, right? See, if you look at the neutron is with a zero charge. So electrical charge is zero, therefore 0 by something is 0, right? Least E by M is for neutron, isn't it? Because the charge on a neutron is 0 by something. Now check out electron. See, the mass of electron is 0. Something by 0 is infinite. Right? So this is maximum. Now coming to proton and alpha particle. Let us check the charge by mass of proton. What is the charge? 1. By mass 1. This is charge, this is mass. So charge by mass is 1. Coming to the alpha particle. Charge is 2, mass is 4. Okay. Now arrange them in a proper order. See, they have asked the decreasing order. So write the one that is with maximum E by M first. Electron has maximum E by M. Of course, neutron has minimum. Now within proton and electron, E by M of proton is 1, whereas that of alpha is half. Now let me write them in this format. Is that correct? Electron, then proton, then alpha, then finally neutron. If the same thing is asked in increasing order, it will be neutron, alpha, proton, and electron in the increasing order. But they have asked in decreasing order, so it is written in this way. Okay, it's simple, charge by mass. Next. A very important question. Look at this. See, an oil drop has 8 into 10 power minus 19 coulomb charge. How many electrons does this oil drop has? Simple. So this is the charge on the oil drop. According to Millikan's oil drop experiment, you know that it is Q is equal to N into E, where Q is the charge on oil drop. N, of course, is an integer, of course, the number of electrons. Can take up values 1, 2, 3, and so on. And this, of course, is electrical charge, or you can say charge on electron. Charge on electron in coulombs, of course, we know that. Come on, let us substitute the things. 8 into 10 power minus 19 is equal to N into what is the charge on one electron? It's of course 1.602 into 10 power minus 19. But let us take it this way simply. You can just cancel out the things. Now, the value of N can be written as 5. So number of electrons in the oil drop is 5. I just wanted to use this relation. You all know that Q is equal to N into E. Okay. Next. Come on. See the mass number of 3 isotopes of an element are 10, 12, and 14 units. Their isotopic abundances are 80, 15, and 5 units respectively. Atomic weight of the element is its Interesting. See, they have given the mass numbers of the isotopes and even their isotopic abundances. I gave you one example when we discussed isotopes, the example of chlorine. Now come on, atomic weight of the element can be given as, you know, isotope with mass number 10 has an isotopic abundance of 80. Then that with the 12 has an isotopic abundance of 15. And that with the mass number 14 has an isotopic abundance of 5. By, of course, some of the percentages, I mean the isotopic abundances, that is 80 plus 15 plus a 5. You just simplify this, you'll get the answer. Let us check. This is 800. This is 180. And this is 70. Of course, this is 100. How much is that? See, this is 980 plus 70, nothing but 1050. 1050 by 100. So it is a 10.5. Okay. So this is how you have to calculate the atomic weight. But in this case, of course, they have given 3 different units, 3 different values with their isotopic abundance. The other day we have taken only 2. And this also is an important one. You actually got this kind of a question in previous I8. Next. Let us take a problem on frequency and wavelength. The Vivid Bharati station of All India Radio Delhi broadcasts on a frequency of 1368 kilohertz. Calculate the wavelength of the electromagnetic radiation emitted by transmitter. Okay, simple. You know, let us just forget about the story that is given, but only thing is, it is clearly mentioned that the frequency of the radiation is 1368 kilohertz. And they are simply asking us the wavelength. So whenever you go for a question, you are asked to solve a question, don't just think about the story. Write the data first. They have simply given the frequency 1368 kilohertz. We know that the units of frequency are hertz or cycle per second. But when they say kilo, multiplied by 10 power 3, right? So 1368 into 10 power 3 hertz or cycles per second is the frequency. And let us calculate the corresponding wavelength. This is the first step. I mean, just check the data first. After that, check whether you know any relation between these two or not. Hope you all know that nu is equal to C by lambda is available with us, right? Let us use this relation now. Frequency is 1368 into 10 power 3 hertz. And then velocity of light. Let us consider that in meter per second. I gave this yesterday itself. 3 into 10 power 8 meter per second. This is in hertz. And now you are asked to calculate lambda. You will get the value of lambda, of course, from this. So that is 3 into 10 power 8 by 1368 into 10 power 3. You can say that this is cycle per second or simply per second. This is in meter per second and this is per second. Okay. So the final answer will be in meters. Let us write that. 3 by 1368 into, when this 10 power 3 goes into numerator, that becomes minus 3. So 10 power plus 8 and 10 power minus 3 can be written as 10 power 5. This is in meters. Now, you know, this of course can be written as, let us do this way. Let us write, because in the denominator there is 1368. Let me take 3 zeros in the numerator. For simplification, I have taken 10 power 3 from this. And only 10 power 2 is what I have written separately. Now come on. 1368. Roughly, you can write that 2 times, right? Point 1368 into 2. Let us take 1300. So that will be somewhere near 2600, right? Then you will be left with say 400. Then that on simplification, when it is 400, it will be near, it has to be checked. A nearby value can of course be written, but here I think we need to check. It comes out to be 2.19 into 10 power 2, nothing but 219 meters. Okay. So that is how you have to calculate. The first step is writing the data, then using the formula that we know we have already derived, then substituting the values and simplifying the thing. It's a simple model. I can give you any number of questions on the relations, what all are discussed. Next. Let me go for one more. The only thing is you have to be little faster with simplification. Come on. Let me just take a question on energy. 100-watt bulb emits monochromatic light of wavelength 400 nanometer. Calculate the number of photons emitted per second by the bulb. This is interesting. They have given power. Of course, wavelength also. And they are asking you the number of photons. Come on. The power of the bulb is given as 100 watts. Do you know that power is energy by time? This watt can be given as 100 joule per second. So watt is nothing but joule per second, right? So anyway, you got energy. The unit of energy is joule, right? Per second. Let us give number of photons emitted per second only. So let us take the relation is equal to, see, normally it is NH nu. Let us now consider N. See, when you write it as E is equal to H nu, that is for one photon. Now this is for N number of photons. Okay, let me write it here. E is equal to H nu. This is for one photon. If you want for say some number of photons, nothing but n number of photons, you can write it as NH nu. Now let us again modify this. E is equal to n into H C by lambda, because you want the number of photons when wavelength is given. You are not given frequency here. Now let us substitute all the things one by one. 100 is the energy. Number of photons is what they are asking. We know, see, this is in joules, nothing but SI system. You need to be very careful. Take the value of H also in SI system. I told you this yesterday. The value of this is 6.625 into 10 power minus 34 into C is 3 into 10 power 8 by wavelength. You know, wavelength is given as 400 nanometer. We know that 1 nanometer is equal to 10 power minus 9 meters. You cannot take it directly. Take it this way. 400 into 10 power minus 9. Now you got everything in SI system. This is in, of course, a joule into second. This is in meter per second. This is in meters. Of course, this is in joules. You will get the value of N. Yes. Let us just simplify this. Look at what we are going to get. Come on. N is equal to, you know, it is, of course, a 4 here. 400 into 10 power minus 9 is 4 into 10 power minus 7, right? 10 power minus 7 into 10 power 2 is 4 into 10 power minus 5. Hope this is clear. 4 into 10 power minus 9, and this is 10 power 2. This is again 10 power 2. Means 10 power 4. 10 power 4, and then this 10 power minus 9. I think 4 into 10 power minus 5 is what we get. By 6.625 into 3 into this is minus 34 plus 8. Nothing but minus 26. Okay, now. Then, yeah, of course. This, if you want, Okay. Finally, it can be written as 4 by 6.625 into 3 into, when this goes into numerator, this becomes a plus 10 power plus 26 and minus 5. How much is that? 10 power 21. Okay. Now, finally, let us do one thing. Let us take, okay, in order to avoid wastage of time, we can do this way. This is what, in fact, we have to adopt. Let us take 10 power 2 from this. That becomes 400, right? Into, of course, 10 power what? 19 will be left. Now, this 6 into 3. Or let us take 6.6 into 3. Leave that 6.625 can be taken as 6.6. 6.6 into 3 is roughly 20. 19.8 is what you get. So let me take it as 20. How much is that? So that comes out roughly as 20 into 10 power 19, nothing but 2 into 10 power 20. Yes, of course, this is what you have to solve. Just cut it simply. Otherwise, if you simplify the 6.625 into 3 and you write that of course will take too much time. Meanwhile, the other student will solve 2 or 3 more problems. So remember, fast and accurate is the mantra. No problem. It doesn't make any problem because now you are given options. Like one option will be with the 10 power 20, the other one will be with 10 power 19, 21, then 23. That's it. There itself you get the answer. So remember, never ever waste time on simplification. I just wanted to say this today itself because this being the first day of the problem. Never ever waste time. Okay. Even if it is like 29 by 6, you cut it like 6 ones are 6 fives are. That is how you can avoid wasting time. And of course, you get some nearby value, which you can see in the option. Okay. Next. One more. A different one. The ratio between the number of neutrons present in carbon atom and the silicon atom with mass numbers 12 and 28 is. Go through the question properly. They're asking you the ratio of the number of neutrons in carbon and silicon. In fact, they have also given the mass numbers. Of course, we also know the mass numbers of carbon and silicon, but what is the atomic number of carbon? It is a 6. And because mass number is given as 12, yes, of course, that is 12. And how about silicon? Atomic number of silicon is 14. Then the mass number is 28. So these are the things given. Now let us take the number of protons, electrons, and neutrons. Just for clarity's sake, number of protons is 6. Even the number of electrons is 6. Because these two are nothing but the atomic number. Now coming to the number of neutrons, it is mass number minus atomic number. Number of neutrons is 6. In this case, number of protons is 14. Number of electrons is also 14. And now the number of neutrons, 28 minus 14. That of course is 14. So now the ratio of the number of neutrons of carbon and silicon. So first carbon, then silicon, right? So the ratio can be given as 3:2. No. Let us, let us give it as 3:7, right? 2 3s are 2 7s are. I think that is okay. So that's how you can calculate the number of neutrons. I mean, the ratio of the number of neutrons. Next. Coming to the next question. We'll take a problem on electromagnetic radiation again. I mean, the nature of light. Okay, look at this. The ratio of the energies of two different radiation. Whose the frequencies are three into 10 power 14 hertz and 5 into 10 power 14 hertz. Okay. So this is again a very interesting one of course, the basic level. They're asking the ratio of the energy and they have given the frequency. So we need to know the relation between energy and frequency. We know that it is, of course, E is proportional to nu, right? Nothing but E is equal to h nu. Even if you know this, it is very clear that E is directly proportional to n. Come on. Let us take E is equal to h nu. Now, E is proportional to n. H is anyway a constant. Just forget about that. So now, E can be written as proportional to nu. Therefore, E1 by E2 can be written as nu1 by nu2. That's it, because they are directly proportional. E1 and nu1 are proportional directly. E2 and nu2 are directly proportional. So this is how you have to derive relation. Suppose you want the relation between E and the lambda. Let us check. We know that is equal to hc by lambda, right? Now from this it is very clear that E and lambda are inversely proportional. Now these two are of course constant. One is Planck's constant, the other one is velocity of light. Now from this I can simply write it as E is inversely proportional to lambda. Now when two parameters are inversely related to one another, you just write it this way. E1 by E2 is equal to lambda 2 by lambda 1. See this. Here they are directly proportional. So you got E1 by E2 is equal to nu 1 by nu. And when they are inversely related, you will get it as E1 by E2 is equal to see lambda 2 by lambda 1. This is how you have to derive relations, whatever are required. Okay, so now let us just substitute the values. Nu 1, the first frequency given is 3 into 10 power 14. And the second frequency given is this. So just 10 power 14, 10 power 14. You just cancel out the things. 3 by 5 is nothing but 0.6. Isn't it? Or you can say 3:5. Right? Next. Right. Let us take a very interesting question. A photon of 300 nanometer is absorbed by a gas and then re-emitted 2 photons. One of the re-emitted photon has a wavelength of 496 nanometer. Then the energy of other photon is. A very interesting question. In fact, IIT advanced the previous question, but a simple one. You just see what is actually being done. You know, it has absorbed a 300 nanometer photon and emitted 2 photons. One of the re-emitted photon has a wavelength of 496 nanometer. This is a wavelength. And see, they are not asking the wavelength of the second photon that is re-emitted out. Rather, they are asking the energy of the other photon that is re-emitted out. So very interesting. Even if energy is not asked, wavelength of the second photon is asked. Remember, you cannot simply take it this way. Lambda is equal to lambda 1 plus lambda 2. No, you cannot take this, because wavelengths are not additive. Then what can be taken? Yes, you can take that the energy absorbed is equal to energy of the photon emitted. Energy of the absorbed photon can be given as hc by lambda absorbed. But let us consider this energy of the photon emitted in two terms. The first one and the second one. Because emission occurred in the form of two photons, isn't it? So now Hc by lambda absorbed is equal to, in this case, let us consider Hc by lambda emitted. But because they are asking the energy of the other re-emitted out photon, I am not writing this in the form of Hc by lambda emitted 2. This is, of course, lambda emitted 1. Let me write this as E2 simply. Now, what is E2? E2 can be written as Hc by lambda absorbed. I mean, I am taking this onto this side. Hc by lambda absorbed minus Hc by lambda emitted 1. Got it? Now, let me just write it as E2 is equal to, take Hc as common, 1 by lambda absorbed is a 300 nanometers. Let this nanometers be taken as common because in the absorbed as well as in the re-emitted out one, we have wavelength in nanometers. So let me take 10 power minus 9 outside. Okay. So if you want, I'll write in 2 steps. Okay, let us take it this way. 300 into 10 power minus 9 meters. This is 300 nanometers minus 496 nanometers. Again the same. So this is what I wanted. Hc by, take 10 power minus 9 outside. So this will be 1 by 300 minus 1 by 496. Now you have to write everything. 6.625 into 10 power minus 34. I mean the value of h. Then 3 into 10 power 8. The value of velocity of light. And then by 10 power minus 9. Then into, of course, the same thing. Now let me write this. 6.625 into 3. Now how about this? Minus 34 plus 8, minus 26. Now then this goes into numerator. It becomes 10 power plus 9. So 10 power minus 26, then 10 power plus 9. That will be 10 power minus 70. Okay. Now take this. When you go for LCM, it will be 300 into 496. Then this will be like 496 minus 300. Okay. So this will be like 196. So you just simplify this whole thing. You will get the answer in joules. If you want, I'll solve that here. 6.625 into 3. Of course, this can be written as 20, sorry. Into, of course, there is 10 power minus 17, but let me take it as 196 by 300 into 496 into 10 power minus 17. So this, let me take it as 20. Even this, let me take it as 200. Then this, let me take it as 300. This, let me take it as 500 into 10 power minus 7. So let us just cancel out the things. 1, 2, 3. 1, 2, 3. Because everything is being multiplied. Hope you are all following. Next, this is 2 into 2. I mean 4 by 3 into 50. It's 150 into 10 power minus 17. Right? Can I just go for 400? I mean, I've made this 400 and let me write this as minus 19 because this is 10 power 2 and this is 10 power minus 19, nothing but 10 power minus 17. Is that right? So even that way it can be written by 150. Now it is very easy to simplify. 152 is a 300. Point 100, right? Round about 6. So 2.6 into 10 power minus 19 joules. Let me just check with the answer given. Okay, let me tell you that the answer given is 2.625 into 10 power minus 19 joules. Yes, we are perfectly correct, isn't it? Though we have taken it simply like 20, 200 and 500, we got the exact answer. Got it? So this way, you have to simplify things in a cut short method. Otherwise, it takes too much time. Okay, let me finally write that as 2.6 into 10 power minus 19 joules. Is that okay? Next. Let's take one more question. This is again a very interesting one. Slowly we are going for some complex models. An electromagnetic radiation of wavelength 484 nanometers is just sufficient to ionize a sodium atom. Calculate ionization energy of sodium in kilojoule per mole. A very interesting question. You need to be very cautious. Now, this is the wavelength required to ionize a sodium atom. I mean to remove an electron from sodium atom, from just one sodium atom. But finally, they are asking the ionization energy of the sodium, not just one atom, but for 1 mole of atom. Point number 1. Of course, we will get the answer if suppose this is taken in meters, we will get the answer in joules. But they want the final answer to be in kilojoules. Let us check. Okay, let us first go for, they have given wavelength and they are asking energy, right? What is the relation between energy and wavelength? We know that it is equal to hc by lambda. Simple, isn't it? That is what we want, whatever may be the type of energy given. Of course, that is ionization energy, but let us take is equal to hc by lambda because that gives the relation between energy and wavelength. Now let us calculate the energy in joules first, then we will give in the units whatever they wanted. What is h here? 6.625 into 10 power minus 34. This is in joule second. Need not say again and again. Velocity of light 3 into 10 power 8. Then the wavelength 484 nanometers. 10 power minus 9 meters. So everything is in SI system. Okay. Now this is in joules. Regular thing what we got. Now this is, let me say that this is in joule per just one atom. Now what I'll do is, I'll convert this joules into kilojoules. Let me multiply this by 10 power minus 3. Then that will become kilojoules, because you know 1 kilojoule is equal to 10 power 3 joule. But 1 joule is equal to how many kilojoules? 1 into 1 by 10 power minus, 10 power 3. That becomes 10 power minus 3. Check out once again. Kilo is 10 power 3. But in reverse, joules to kilo. 1 kilojoule is equal to 10 power 3 joules. But 1 joule is equal to 10 power minus 3 kilojoules. I've given the clarity. Now, but this is only for one atom. And finally, they wanted it in mole atoms. They wanted it for mole of atoms. So let me multiply the whole thing by Avogadro number. We know that mole is nothing but Avogadro number. Now this is kilojoule per mole of atom. Same thing, same thing, same thing. Now let me write the final step. Okay, as usual, we will simplify this here. Come on. 6.625 into 3 by 484. See, this is minus 34, this is plus 8, minus 26. Now, when this goes into numerator, it becomes plus 9. 26 and plus 9 is minus 26 and plus 9 is minus 17. Okay, so minus 17, and say here you got minus 3. And then there is a 6.023 into 10 power 23. Come on, let us finalize this. Okay, now let me take the way I am simplifying this. Check out, this is 20. 20 into 6, 120. 120 by, this is 500, roughly, minus 20 plus 23. So plus 3. Got it? So this is roughly, if you consider this as 125 and this as 500, that will be 1 by 4, nothing but 0.25 into 10 power 3, nothing but 250. Okay, this is 250 kilojoule per mole. Let us check what the answer given in the option. Yes, they have given 246.9, 594.5, 694.5, 794.5. Then what is going to be our answer? It's going to be 246.9, because our answer is nearby that. So this is how you have to avoid wasting time. Let me just check whether our answer is correct or not. Perfect. Yes, the answer given is 246.9. But for that, if you want to get that, I think it will take a minimum of 2 to 3 hours. By the time, your exam time will be over. So never ever waste time in going for the complete simplification. Look at the way I have simplified. See, I have taken this as 20, this as 6, this as 500, too much. And even finally I got 120. But even that also I have taken it as 125. And then finally I got it as 1.4. And that is 0.25. Then that becomes 250. So this way you have to simplify. This is what I wanted to say. Whatever heavier the problem is, don't worry. Just see, this problem is of course having too much of simplification, but only thing is it is based on the relation E and lambda, right? So that is very interesting.